Hi, my name is Stephen Guerin. I'm the Chief Technology Officer of SimTable, and I just want to show you today how the sand table works here. This is just ordinary sand. We put in a sandbox, and as we move the sand, we're able to create a 3D topography. Now we're set up with the same 3D topography, and I'm going to let the computer scan it.
And here is the result. We will color by elevation. The highest points will be colored in green, and then cyan, blue, and magenta. The next feature is to load an area of interest. I will go out to the USGS Seamless Data Server and load the elevation model for Santa Fe. The computer will tell me where to move the sand from red to green to make Santa Fe. And now we have a fully rendered version of Santa Fe with the high mountains in the northeast, the river valley, and the plains to the west. The next feature is to load a vegetation model. This can come from a fire behavior analyst or from a GIS server. Once we have the vegetation, we have two of the components that we need for a wildfire. We have the elevation, which gives us the slope as fire likes to go uphill, and we have different types of vegetation. We have pinyon juniper, some grass, and some ponderosa pine. The last thing we need is the wind vector. So let's start a scenario here with the wind coming out of the west. I will load a simulation of a wildfire and actually spark it with a live lighter. That lighter will trigger the start of the fire, which I'll do here. You can see the fire lighting, which is simulated following the terrain and the wind and is responding to areas of vegetation. The wind is pushing it to the east and the fire is spreading uphill and downwind. I'll now move the wind vector in real time, coming out of the northwest, pushing the fire to the southeast. If I reduce the strength of the wind, you'll see it's much more of a topographically driven fire, moving uphill and ultimately burning itself out.
We have another scenario loaded. We have a road layer, indicated by the lines. We have the housing layer, indicated by these red dots, and the blue dots represent the traffic. We're looking at the evacuation dynamics of this fire that's spreading to the east, and we're seeing backed up cars as the evacuation proceeds. This is a useful tool for multi-agency response where the police and sheriff need to coordinate with the fire department on the evacuation of this event. Because the simulation is in 3D, we're also able to visualize the flame length in addition to the spread rate. We're also able to look at the smoke dynamics, which is very informative to community outreach programs. People can get a sense of what the smoke would look like as they're trying to evacuate their homes. Some people believe that they can outrun a fire that just moves at 2 or 3 miles per hour. But when you take into spotting into effect as well as the smoke and other drivers on the road, they realize that evacuation may be very difficult.